Today we're going to explore the two-dimensional characteristic of an explosion. So we're going to go in the X and the Y direction. So what are we talking about? We're talking about we have some sort of object and it might split into 3 pieces. Okay, maybe this piece goes straight up, and this piece goes diagonally, and this piece goes diagonally. Okay, so conservation of momentum still applies, but instead of just doing straight conservation of momentum, we have to deal with your X momentum, and we have to deal with your Y momentum. We have to take care of these guys separately. So let's look at an example. Nobody said to do that. So I gave our chunks some masses and I gave them some velocities. And what we need to do is we need to find the velocity and the angle that this last piece goes off at. So that's basically what we're trying to do overall. And so we need to deal, like we said, we need to deal with our X separate from our Y's, but no matter what, momentum is still conserved. Okay, so in the X direction, your before is going to equal your after. Okay, and in the Y direction, your before is going to equal your after. So beforehand, our chunk here, the whole big 10 kilogram, or was that 11 kilogram chunk here, is stationary. So its momentum before anything happens is 0 in both the X and the Y direction. So in the X direction, before is 0, and that's going to equal after. Okay. So after. Okay. So this 2 kilogram piece in the X direction, it's going 10 meters per second straight up. Straight up. How much of that is in the horizontal X direction? None of it. Okay. So we can go ahead and we can write 2 times 0 just so we know, make us a little happier. And then we have this 5 meter per second, or this 5 kilogram piece. So we're going to add that 5 kilogram piece, and it's going at 5 meters per second, but it's going at 30 degrees. So not all of that 5 meters per second is totally in the X direction. We need to find its X component. So remember, that's cosine 30. And then our 4 kilogram piece is actually going in the opposite direction. So instead of adding it, what are we going to do? Yeah, we're going to subtract it. 4. And then we don't know that X velocity, so we're just going to call it Vx. All right, in the Y direction, we have 0 before. And then after, we have that 2 kilogram piece. Now it's going 10 meters per second straight up. And do you see the 5 and 4 kilogram pieces here are going down? Do you see that's going down and that's going down? So they're in opposite directions, opposite signs. So instead of adding, just like we did before, we're going to subtract that. So the 5 kilogram piece is going 5 meters per second, but we need the Y component, so we're going to go sine 30 minus, because in the Y direction the 4 is going down still, 4Vy. Okay, so go ahead and pause the video, solve for Vx and Vy, and we'll come back and check our answers. Okay, so in the X direction, I got that we were going at 5.41 meters per second. And the Y direction, I have that we are going 1.875 meters per second. Did your answers agree? Yay! So here's what we know right now. Our x velocity is 5.41 meters per second. And we know it's that way because we said that subtracting was to the left. And our y velocity is 1.875 meters per second. So we need the overall velocity. We want the resultant. Okay, so a squared plus b squared equals c squared. 5.41 squared plus 1.875 squared is equal to our overall velocity squared. And we get squared plus 0.41 squared is, the square root of the answer is 5.73. And then we need the angle. So inverse tangent of our y over x. Our y was 1.875. Our x was 5.41. So the inverse tangent of that (19.1 degrees). So our last little piece, our little 4 kilogram piece, is going 5.73 meters per second at 19.1 degrees down and to the left. Okay, so some things to notice here. Notice that our little tiny piece, our 2 kilogram piece, hold on here. Okay, our 2 kilogram piece was going 10 meters per second. Our 4 kilogram piece was going overall 5.73 meters per second. And our 5 kilogram piece was going 5 meters per second. And generally you will find this to be true, is that your largest piece is going to be going the slowest and your smallest piece is going to be going the fastest. Now, which piece do you want to get hit by? You want to get hit by the piece with the least amount of momentum, because that's going to require the least amount of force to stop. So this one has 20 kilogram meters per second. Oh, what is, well, 4 times 5.73 is more than 20. This one's 22 kilograms meters per second. And this is 25 kilograms meters per second. So in this case, we would like to get hit by the smaller piece. Now, that smaller piece is going pretty fast, so it's still going to sting. And it doesn't always come out that the smallest piece has the least amount of momentum, but this is the one we want to get hit by. All right, so remember, overall, we had to separate our x and our y, so we had to find our x momentums, and we had to find our y momentums to get our x velocity and our y velocity. And then we did the Pythagorean theorem to get the overall, and we did the inverse tangent to get the angle. Okay, so once we had the x and the y, we Pythagorean theoremed an inverse tangent, just like we did when we did vectors way here at the beginning. So this brings us all, wraps up the whole semester and brings it back together.